Okay, sorry about that again, guys. I haven't been having the luck of uninterrupted videos. Anyways, step 3. So we've had the test, we've passed on both accounts, we've calculated the mean and the standard deviation. Now it's time to actually, how are we going to answer this question? Okay. Now, before we jump into it, I want you to recall this chart right here, okay? And what I want you to recall is that we were being asked the probability that between 8 and 15 girls would read the morning prayer. Now, when Miss Staples created this chart, she obviously rounded the probabilities to 4 decimal places. So we are going to understand that there's a ton more decimal places on each of these numbers. But if I add these numbers, this should give me a very good, very strong indication of what the answer to that question. So I'm going to give you a heads up. If you add this, and this, you're going to get 71.71%. Again, obviously it's rounded because we took everything to the 4 decimal places. So if you could keep the number of 72% in your head, I'd really appreciate that. Because remember what the question was asking. What is the probability that between 8 and 15 girls read the morning prayer? Keep 72% in your brain. Okay. Normal approximation. Now, we know that when we use anything that's normal, we use the z-score formula. Okay, so I'm going to write it down twice because this is a between question. I know that the mean is 8.8. And I know that the standard dev is 2.22. We've calculated that a number of times. The issue becomes, what number am I going to put in those hot pink areas? I'm looking between 8 and 15. That's the probability that I'm looking for, between 8 and 15 girls. I cannot use 8 and I cannot use 15. Why? Because they are discrete values. And to run a normal curve, you need to use continuous values. So we discovered that the range of 7.5 to 8.5 would simulate 8, and the range of 14.5 to 15.5 would simulate that 15. So the question is, for this area, am I going to use 7.5 here, or am I going to use 8.5? And the question is, for this hot pink area, am I going to use 14.5 or am I going to use 15.5? Well, the way you answer that question depends whether you're including 8 and 15 in your answer. And we are. We are including 8 girls and we are including 15 girls. Probability of 8, 9, 10, 11, 12, 13, 14, and 15. So if I'm including 8, I'm going to start my highlighting process right from 7.5, and I'm going to extend it all the way to 15.5. So 7.5 and 15.5. Now, let me just clarify that just for a second. If I would have started the highlighting process from 8.5, it wouldn't have included highlighting 8. And if I would have ended the process at 14.5, my highlighting process, I wouldn't have been including 15. So the reason that I chose 7.5 is because when I highlighted, I went over and I included 8, and I went all the way to 15.5 because it will fully include 15 as well. Okay, I'm going to do my calculation, 7.5 minus 8.8 divided by 2.2. Remember, when you do your z-score, you only want 2 decimal places. I'm going to get out my z-score table, and I'm going to look for negative 5.9 on the chart. And when I do, I'm getting 27.76%. Okay, I'm going to do my calculations. 15.5 minus 8.8 divided by 2.2. Remembering that my z-score should have only 2 decimals. Ooh, this number seems weird. We shouldn't have anything over 3. So that's going to mean that my z value is decimal 9999. Okay, remember, when we get over 3, it's an outlier. You're almost saying 100%. I could actually allow if you would have used a z value of 1 as well. Okay? Now, the between question says, take your 2 percentages and subtract them. Didn't we have an answer of roughly 72%? Now, I understand it's not the exact same answer. Okay, I understand that. Don't forget, this one is off a little bit because it's missing the decimal places. This one is off a little bit because this is called an approximation. So in my therefore statement, therefore, approximately, or there is, sorry, approximately a 72.23% chance of between 8 and 15 girls reading the prayer. Now, right now you're probably thinking, how is this saving me time? Like, this note is long, it's excruciating, you know, how is this save me time? What we're going to do next is we're going to run through an example without all the theory mumbo jumbo. Okay, we're going to run through a beautiful example and just do the question using the normal approximation without all the discussion and without all the theory. Okay, when you're ready, let's flip. A card is drawn from a standard deck and it's replaced. If we repeat this 60 times, what is the probability of getting a heart exactly 12 times? So again, this is 2 outcomes, heart or not. The word exactly is the classic Bernoulli. So number of trials, 60. Number of successes, 12. Probability of a success is getting a heart, 13 out of 52, to the number of successes. Probability of failure is not a heart, so club, diamond, spade, to the number of failures. 60 trials, 12 successes, 48 failures, 8% chance of happening. Classic Bernoulli, nothing new. What is the probability of getting fewer than 15 hearts? Now, hold on. Fewer than 15 hearts means everything from 1 all the way to 14. Because fewer than 15. That would mean that we would have to run Bernoulli 14 times, this formula, 14 times to get the answer. That seems absolutely ridiculous. Okay, that would take you a ton of time. So you're thinking, geez, I don't want to run Bernoulli 14 times. Maybe, just maybe, this particular question can be done using the normal approximation. Well, step 1 is the test, NP, NQ. N being 60, probability of success being a heart, 13 out of 52. N being 60, probability of failure is being anything that isn't a heart. So 16 times 13 over 52 is 15. Bingo bongo, I've got my 5. 60 times 39 over 52 is 45. So both values are greater than 5. This technique is a go. Step 2. Please calculate your mean, which is your NP. Already done it. And please calculate your standard deviation, which is your square root of 60 times 13 over 52 times 39 over 52. And remember, I said to you, be really careful with your calculator. This is an easy spot to make a boo-boo. 3.35. So step 1 is done. We've passed. Step 2 is done. Here comes step 3. Step 3 is the normal approximation portion. So I know that the average is 15. I know that the standard deviation is 3.35. My issue is, what am I going to sub in for my x value? Again, let's look at it from a number line. Fewer than 15, I know, are all these numbers to the left of 15. Things that are smaller than 15. I know that I can't use 15 in here because 15 is a discrete value, and I'm not allowed to use that. I know that the range of 14.5 to 15.5 will constitute that 15. So my issue is, am I going to put 14.5 in here, or am I going to put 15.5? Well, fewer than 15 means that 15 isn't included. So if 15 isn't included, I'm going to use the 14.5 because 14.5 going to the left doesn't allow the inclusion of the 15. If I would have chosen the 15.5 and highlighted, 15 would have been included, and I don't want that. So 14.5 minus 15 divided by 3.35. Oops, sorry guys, put my decimal in the wrong spot. Gives me a negative 0.15. I am going to look that up. Negative 0.15. And that's giving me a Z value of 0.4404. So if I want fewer than 15 hearts, that's this region right here. Therefore, there is approximately a 44.04% chance of getting fewer than 15 hearts. That's a classic normal approximation question right there. I know the note took a long time, but this is what I'm going to see in your homework. This is what I'm going to see in your test. Now, the area of pitfall is 2 spots. Right here, so be very, very careful. And the other spot is right here. And you really have to stop and think. I like using the number line. You have to stop and think, are you including or are you not including? Okay? Any questions, please send them my way. Like I said, there's 2 little areas that cause a bit of a kerfuffle. Here with your calculator and here with your choice. But don't hesitate to email me with any questions. Okay? Take care.